Okay, hello. In this video, I want to talk about our dataset paper, a tightly controlled fMRI dataset for receptive field mapping in human visual cortex. And this dataset was originally acquired by Jakob Heinzle and London Haynes, and then curated by my colleague Kai Görgen. And I took this dataset and converted it to the BITS dataset and uploaded it to OpenNeuro, where it is available now. So since this is about visual receptive field mapping, I'm going to start by explaining the experimental paradigm here. So in our experiment, subjects were viewing such a dartboard-shaped stimulus, and this was consisting of several individual sectors, and each sector was showing a flickering checkerboard pattern at a certain illumination intensity, so sometimes darker, sometimes brighter. And then every 3 seconds, the illumination intensity or the visual contrast levels of all sectors were changing, flickering checkerboard again, 3 seconds, all the levels were changing, flickering checkerboard again, and so on for 100 times during one fMRI run. So the stimulus that we used can be subdivided into 48 individual sectors, which are organized in 4 rings from inner to outer, and in 12 segments, which correspond to the angular direction within the visual field. The dataset is characterized by a very low number of subjects because it consists of only 4 people who also took part in a retinotopic mapping experiment that generated region of interest maps for the visual areas V1 up to V4, and these maps are also included in the dataset. However, the dataset has a very high number of trials per subject. So as I already said, the intensity levels changed every 3 seconds for 100 times during one fMRI run, and there were 8 runs per subject, meaning that there are 800 trials of continuous visual stimulation in this dataset per subject. So all the details on the dataset, including file formats and fMRI acquisition parameters and where to find it on OpenNeuro, are included in this data specifications table, which is also part of the dataset paper that was published in Data in Brief 2 years ago. So in the second part of the talk, I now want to give you an impression of what kind of analyses can be done with this dataset, especially with respect to visual reconstruction, that is recovering sensory input from measured fMRI signals. So in the original study, for which this dataset was acquired, the idea was to extend this concept of sensory receptive fields, mapping from sensory space to primary sensory cortex, to the idea of cortico-cortical receptive fields, mapping from primary sensory cortices to higher areas, such as V1 to V3 in this case. And in this way, the authors were able to show that there is a retinotopically organized functional connectivity structure between the visual field maps from different areas in the human visual system. So about 10 years later, we then took this dataset again and used it for visual reconstruction analyses. And here the focus was especially to compare 3 methods of trial-wise parameter estimation, which are called least squares all, least squares separate, and inverse transformed encoding models, or ITEM in short. And here we could show that ITEM was significantly more accurate in reconstructing the individual sectors' contrast levels from fMRI activity in primary visual cortex. More recently, we then extended this to searchlight-based analysis. That is, we implemented searchlight-based ITEM decoding, and by doing this, we were able to or by applying this to the same dataset, we were able to recover several well-known properties of the visual system, such as the representation of left and right visual hemifield in right and left visual cortex, the representation of top-bottom visual field in medial versus lateral parts, the representation of eccentricity along a posterior anterior axis, and the representation of angular direction along a dorsal ventral axis, which together, of course, form the polar coordinate representation of the visual field in the human visual brain. So with that, I want to thank you. And if you want to know more, or if you want to use the dataset, feel free to have a look at the paper.